Welcome. This video corresponds to section 6.2 from Math in Our World. This video will cover two topics, solving linear equations and then justifying the steps to solve a linear equation using properties of real numbers and properties of equations. Some basic definitions to start. An equation is a statement that two algebraic expressions are equal. So remember that algebraic expressions are made of numbers, variables, operations like addition, multiplication. And when we have two expressions on either side of an equal sign, that would be an equation. A solution of an equation is a value of the variable that makes the equation a true statement when substituted into the equation. Here's a math note. Equations can have any number of solutions. We will work first with linear equations, which have one solution. You may have also solved quadratic equations before, which have two solutions. And some equations can have many solutions, an infinite number perhaps, or none at all. Okay. Example 1, identifying solutions of an equation. Decide if the given value is a solution of the equation. So we need to substitute the value of the variable for the variable in the equation and see if it makes a true statement. Okay, so replace, every time you see an x, replace it with a 2. And then use order of operations, or you could also use properties to simplify this. So if I do order of operations on this, I would start with the parentheses and then multiply. Okay, and that's false. So this is not a solution. And if I used properties to do this, alright, the only thing you don't want to do is move things side to side. So we're trying to decide if this is a true equation. So for instance, I can't divide by 4 because I don't know, that's something that we do to true equations. But I can use the distributive property. That would be okay. So, in this case, I think it's easier to just do 2 minus 1 to begin, but if you wanted to, you could distribute and do 4 times 2 is 8, 4 times 1 is 4, and then finish the problem that way. And you should still get the same answer whether it's, true or false solution or not. Alright, the next one, substituting 8 for x. 8 plus 7 is 2 times 8 minus 1. Alright, and I'll put an arrow. If you need to show, that you're moving from one equation to another, use an arrow. Don't use another equal sign, because then, you're kind of combining more than one equation. Okay, so here we have 8 plus 7 on the left-hand side, and on the right we have 16 minus 1, and that is true. Alright, so x equals 8 is a solution. And then finally, 2y squared equals 200. Alright, here we have an exponent and we have a negative variable, so it would be a good idea to put a parentheses around that when you substitute. Okay, and then I'm just filling in the parentheses instead of a y, I'm filling it in with a negative 10. Okay, order of operations, negative 10 squared. This is negative 10 times negative 10, so that's 100. And that is a true statement. Okay, linear equations. So we mentioned before there are linear equations, quadratic equations. A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers, and a is not 0. Alright, so if a was 0, we wouldn't even see an x in this equation, and then it's not linear. Alright, so that requirement just guarantees that we do have that variable x. And then we are allowed to have, something multiplied by the x, and we can have something added to the x. Alright, but what we don't want to see are things like x squared or another variable or something like that. Now keep in mind that this definition says that it can be written that way, so there may need to be some work that gets done to be able to see that it is a linear equation. Okay, so looking at part A here, let's see, our task is to decide which of these equations are linear. So the first one, you can almost visualize how this would, get into the form that's required. But if you can't see it, then let's maybe do a little bit of work to simplify. All right, so if you distribute the 2, all right, then we could move this 2x over, all right, by subtracting. And we'll go through this in more detail if you, forget these steps and how to do this, but this may be a review for many of you. All right, and then subtract 2. All right, and then there's my form. So if I try to write this as ax plus b, this is really a 1x plus a 0. Oh, whoops, I can move that 8 over. Sorry, let's back up. I actually did not want to move the 2. I want to move everything over to one side of the equation, so I want to add 6. Okay, and then I get x plus 8 equals 0. Alright, so this is now 1x plus 8 equals 0. So here's my a is 1. Here's my b, 8. And then I have ax plus b equals 0. Alright, so you don't need to do all that work every time, but if you have one that you're not sure about, see if you can rewrite it in that required form. Okay, so part A is linear. Y squared minus 4 equals 0. Well, right away I can tell because the exponent on the variable is not a 1 that this is not linear. Okay, on part C, we see an exponent, but that's okay. That's just on the 3. So that's going to make that 1/2 t minus 9. So that's not a problem. And I do have a variable. All right. And even though your definition says x, I don't know why your textbook did this, but even though it says x, it could be a different variable. So it's not a problem that it's a t. We're looking to see if this can be like a t plus b equals 0. All right, and then the other things in this equation, I have something multiplied by the t, that can be the a. I have something here that could be the b, and then I would just need to move the 10 over to get this equal to 0. So that's going to work out fine. That's going to be a linear equation. Okay, and then part D, the exponents are 1, so initially it looks okay, but think about what would happen if you distributed this x. We would end up with x times x, that's x squared, plus 3x equals 4, and then this is not linear because we have an exponent that's not equal to a 1. Alright, let's talk about solving linear equations. So first of all, the idea of an equivalent equation. These are equations that have the same solution set. Alright, so x minus 3 equals 0 and x equals 3 would be an example of two equivalent equations. Both have the solution, and we could even write this using that notation from set theory, using the listing method. Alright, here's the solution set, the set containing 3. So our strategy to solve a linear equation is to perform one or more steps that transforms one equation into an equivalent one, and you keep doing this until you get to the point where the solution set is obvious. Alright, so for example, if we had been given this problem, x minus 3 equals 0, right, then you may remember to solve, you're supposed to add 3 to both sides. So we're transforming the equation. And then here, this is actually just a one-step problem, but we've transformed it to the point where we can easily see all of the different values for x. And for linear equations, your solution set's just going to have one answer in it. Alright, so how do we transform these equations? Well, we have all of the properties of real numbers that we can use, but we need something else. We need properties for equations. So here are the first two, addition and subtraction properties of equality. And these are the rules that let you add or subtract something to both sides of the equation. And I'm sure you've heard variations of this when you've learned how to solve equations. You may have heard what you do to one side, you do to the other. You may have heard the analogy about an equation being like a balanced scale. Okay, and you can put the same thing on both sides. Okay, if I add, 3 over here, then I add 3 over here to keep this balanced. Okay, so in symbols, if we know that A equals B, right, that's my equation, and I can fill this in with anything, so it might be something like 2x plus 5 equals 16x. Well then here all of this is my A, and here's my B. Okay, and then this rule says that I can add something, doesn't matter what, the same thing to both sides, or I can subtract something from both sides. Alright, so let's practice this. Solve each equation and state which property you used. So either addition or subtraction property of equality. Okay, and then check your answer. Okay, so x minus 5 equals 9. Well, to solve this, I want to transform this to the point where I have just x equals. So what I don't want is that minus 5. Alright, so if I add 5 to both sides, then I get x minus 5 plus 5 equals 9 plus 5. Alright, and then notice because I added something to both sides, that's the addition property of equality. And I'm going to start abbreviating these POE. Okay, so if you see that, that's property of equality. Alright, so then on the left I have x minus 5 plus 5 is 0. And on the right, 9 and 5 is 14. And then x plus 0 is just x. Alright, so that is solved. Checking the equations. You don't have to do this every single time, but it's a good idea just to review and remember how. So you would, to check if this is a solution, this goes back to the first example we did in this video. Right, just substitute in the value of the variable into the original equation and see if it makes it a true statement. So the check would be, substituting 14 in for x and seeing if this is true. 9 equals 9. Yes, that's true. All right. Okay, the second one. We have y plus 30 equals 110. So to solve, I would need to subtract 30 from both sides. And then my equivalent equation is now just y plus 30 minus 30 is 0. And then 110 minus 30 is 80. Okay, now I subtracted 30, so this is the subtraction. Subtraction property of equality. Okay, one other note about these properties. You can either use addition or subtraction for all of these. So, yes, I'm subtracting 30, but if you wanted to think of this as adding a negative 30, it's really the same thing. So you would be also correct if you stated that this was the addition property of equality. And in fact, it does vary from textbook to textbook whether they even state that there is a subtraction property. Some textbooks just say it's only the addition property, and every time you're subtracting, it's just like adding a negative number. Okay, 2 more properties for when the equations involve multiplication and division. Right, same sort of an idea. You can multiply or divide both sides of an equation by the same non-zero real number without changing the solution set. So you can't multiply by 0, and we'll talk about that more later, why that's not okay. All right, but basically it is, you might end up not seeing some of the possible solutions if you do that. All right, in symbols, here's our equation, A equals B. Then you can multiply something to both sides, so for example times C on both sides, or I can divide by C. And remember, you can write A divided by C, but it's usually better now that you're working with algebraic equations to start writing these as fractions. Okay, so dividing by c like that. Okay, solve each equation, state which property you used. So either multiplication or division, property of equality. All right, so the first one, this is t, and I would read this t divided by 6 equals 3. All right, so the part that I don't like is the fact that t is divided by 3. I just want to know what t is. So we can multiply to undo division because those are inverses. Okay, so I'm going to multiply by 6 over 1 on both sides. All right, and on the left I have the 6's, all right, cancel each other out because that's 6 over 6, which is just 1. Okay, so I end up with t divided by 1, which is just t. And then on the right I have 3 over 1 times 6 over 1, or just 3 times 6, and that's 18. Okay, we multiplied, so this is the multiplication property of equality. Okay, second example, 5x equals 30. Well, this time I have something multiplied by x, so I would like to divide to get rid of it. Divide by 5. And on the left, 5 divided by 5 is 1, so that's canceled. And this becomes x equals 6. All right, now same thing here. This is dividing by 5, but it would also be the exact same if you multiplied by 1/5. So this goes back to a rule that you learned probably in a previous class. When you divide by something, it's the same as multiplying by the reciprocal. So I could divide by 5 or multiply by 1/5. All right, I'm going to get the same thing, x equals 6. But then also notice that we could also say that this is the multiplication property of equality. And again, it differs based on which textbook you use, whether or not they even consider division property of equality to be a property. So here again, either one is correct, either division or multiplication in any example that's like these. All right, your procedure in general for solving linear equations. So these are the steps that will always work. You can always simplify the expression as much as possible, and that's a good idea to do at the beginning just to make things easier. So examples would be if you see parentheses, you want to distribute right away. Okay, and then it's a good idea to combine like terms as well, just so you don't have to keep moving more terms than necessary to the other side of the equation. Step 2, use the addition and or subtraction properties of equality, and the goal here is to get all of the variables on one side. Okay, so if we had like a 3x and a 6x, maybe it's a minus or something like that, and then all the constant terms to the opposite side. So if you had a 5 or a 16, okay, so variables on one side, constants or numbers on the opposite side. Combine all the like terms, and then use multiplication or division to eliminate the numerical coefficient and solve for the variable. All right, one thing that's interesting here, even the steps for solving a linear equation are not something that's new. We are basically just doing order of operations but backwards. So you have learned, when we're simplifying expressions like 3 times x plus 2 minus 5, something like that. Okay, so let's see. Let's write PEMDAS. All right, so simplifying, you follow order of operations in this order. All right, that's to do arithmetic. Now when we're solving, we're trying to undo arithmetic that's been done to x. Right, we want to find x and get rid of all of this other stuff. So to undo things, we go backwards. All right, and so then notice that that's why we're doing here in step 2 addition and subtraction first. It's because we're undoing those things. Okay, and then we do multiplication and division. We undo those because that's what comes next in order of operations. Okay, a couple examples of solving a linear equation. All right, so here this looks fairly simplified. I don't see anything that we can do on the left side or on the right side. All like terms have been combined. There's no distributing. So now I want to actually start solving and moving things around. All right, so first thing I do is try to get all of the variables on one side and constants on the other. So this side just has a constant, so I'm going to make this the constant side, and I'll put variables over here. All right, so on the left I need to get rid of that 9 because it's not a variable term. So I'm going to use addition or subtraction property of equality. Subtract 9. 5x equals 20. And then here's the coefficient that I would like to get rid of, the 5. So I'm going to use the division property of equality, divide both sides by 5, and you get x equals 4. Okay, here's another one. Here I have variables and constants on both sides, so I'm just going to pick one side to be the variables. I like to have a positive coefficient on my variable, so if I'm combining 6 and 4, I'm going to need to subtract one of them. So I would rather subtract 4x so that I end up with a positive coefficient on the x. Alright, so I'm going to make this the variable side and this the constant side. Okay, so on the left I would have 6x minus 4x is 2x. Right, and I'm kind of skipping a couple steps here that I'm combining like terms right away. And your textbook says that I should wait until step 3 to do that. So they move everything first and write it all out. All right, so I'll save a step here. Okay, so I'm just kind of going through. I've done these variables. I've copied down the negative 10. I've subtracted 4x minus 4x. And then I have a negative 8 that's left. All right, and then I'll add 10 because I'm still trying to get the constants to the right-hand side of the equation. So I have 2x, minus 10 plus 10 is 0, and then on the right, 10 minus 8 is 2. Okay, variables on the left, constants on the right. I've combined all like terms, so the last thing to do is get rid of this coefficient, the 2, and I'm going to divide by 2 to do that. So I end up with x equals 1. Alright, this one has some simplification that can be done. So first thing I want to do is start with distributing. Alright, I see a parentheses with something outside of it, so that's the clue. Alright, so 3 times 2x is 6x, 3 times 5 is 15. Okay, now the right-hand side is fully simplified. I can't combine those, they're not like terms. But on the left-hand side, I do have a couple like terms that I can combine. So I'll do that now. 15 minus 10 is 5. Okay, and I'm going to move the variables over to the left, constants over to the right. So subtract 3x. Right? And if I wrote this all out, this is how your book does this. Right now, they're going to write this as 6x plus 5 minus 3x equals negative 10. Okay, and then they'll move this 5 over by subtracting. 6x minus 3x equals negative 10 minus 5. And now they combine like terms. 3x equals negative 15. And then I'll draw an arrow, not an equal sign, to show that I'm moving on to an equivalent equation. And I'll just recopy this. Alright, and now I need to do the last step, divide by 3. So that gives a coefficient of 1. 1x equals negative 5. Okay, this is the start to some information that is not explicitly stated in section 6.2 of your textbook. All right, so you may want to just watch this part if this is new information for you. Okay, so we know that the goal for solving equations is to transform the equation until it looks something like x equals a number. So in the previous problems, we did some examples of those 4 steps using the properties of equality to move things until we got our answer like that. So what we want to do in these following problems, I've actually written out all of the steps to solve the equations. They are already solved, but what we want to do is justify the properties that we used in order to solve those equations. So we're basically just giving reasons for all of the work that's been done. So here are the options. You can choose from the real number properties, commutative, associative, distributive identity, inverse, and we don't use the closure property for solving equations, so that's not listed here. And then we have the properties for equations, addition, subtraction, multiplication, division, properties of equality. So these are the ones that let you do things to both sides of the equation. Alright, so here's problem 1. There will never be a reason for the first step. This is just the given problem. And if you remember proofs from geometry, this kind of starts the same way. You can think of this as like a 2-column proof. Some of you might be groaning right now if you hated those. But on the left we have the work or the statements. And then on the right we have the reasons. So reason for step 1 is always that it is given. Okay, step 2, we need to give a reason that explains how we got from step 1 to step 2. What transformation did we make? So you want to focus on the part that's different. Well, I see a +2 here that was not in step 1. Alright, so I need to figure out what property allowed me to put those +2's there. Well, I'm adding something to both sides of an equation, so that's the addition property of equality. Okay, now don't just say addition, because addition just means, like, that's the definition of addition, just adding. Alright, so you need to make sure you put this property of equality part. That's the reason that lets you do things to both sides. Okay, then in step 3, I need to look from step 2 to step 3 and see what changed. Well, I see 2 things. I see 8 plus 2 equals 10. I'm just going to ignore that because that is just arithmetic. There's no property there. Alright. But on the left, I see -2 plus 2 equals 0. So if I pull that part out, what I'm really asking is there a reason that I can use to explain why -2 plus 2 is the same as 0 or equals 0? Well, yes, it's sort of just addition, but this is one of the special answers. So look for addition problems that have 0 as an answer, and you may recognize this from properties of real numbers. This is the inverse property. So this works because -2 and 2 are inverses. Okay, and then the next one, I need to explain why x plus 0 equals 10 is an equivalent equation to x equals 10. Alright, well the part that's different, I see a +0 here, and I don't see that there. Right, so I need a property that explains why x plus 0 is the same thing as x. Alright, you may recognize that one as well. That's the identity property. Anything plus 0 just equals itself. Okay, so that's it. We have given reasons for all of the steps for this problem. Alright, problem 2. I've given you 2 ways to work this out. On the left, right, here's the given. Step 2, the new part is that there's a 1/4 being multiplied on both sides of the equation. So that is the multiplication property of equality. Okay, and then the next step, all right, on the right I just have some actual multiplication, so I'll ignore that. I want to focus on the left hand side here, the fact that 1/4 times 4 was replaced with a 1. Okay, that should look like one of your properties of real numbers. That's the inverse property again, just this time for multiplication. All right, so if you see a step that's it looks just like normal arithmetic, check if the answer is a 0 or a 1, and if so, then consider whether or not it's the inverse property. And then finally, the last step. All right, the right-hand side looks the same, but on the left, I've replaced the 1x with just an x. All right, well, this is the identity property for multiplication. 1 times anything equals that thing, that number. All right, on the right-hand side here's another option. So step 1 is still given. Now step 2, we're dividing here, dividing by 4. So you could also write this a little differently, and then this would be the division property of equality. All right, but remember from before, these are really interchangeable since dividing by 4 is the same thing as multiplying by 1/4. So either one is an appropriate answer regardless of how it's written. All right, now this step, on the left we have 4 divided by 4 equals 1. Okay, can we give a reason for that? This one I think is easier to see now that we've done the left-hand side over here. All right, this is another example of the inverse property, because what I'm really saying when I say 4 divided by 4 equals 1, I'm really saying that 4 times its inverse equals 1. It's the same thing. All right, so anytime you have something like that with 1 as an answer, that's going to still be the inverse property. Okay, and then the last step is the same. 1 times x equals x. So that is still the identity property. All right, here's a slightly longer problem. Okay, let's see. This step should be lined up over here. I'm not sure why that moved. Okay, so let's see what we have. We have given first. That's the problem. What changed to the second step? Well, it looks like the 5 has been multiplied into the parentheses, so that's the distributive property. Okay, and then looking between that line and the next line, the new part is a minus 30 on both sides. So this is either addition of negative 30, or you can think of this as subtracting 30. So subtraction property of equality. All right, then the next step, 20 minus 30 is negative 10. I'm going to ignore that. That's arithmetic. But here's the part that I want to notice. 30 minus 30 is 0. All right, it is just arithmetic, but because the answer is 0, this is one of those special ones. This is the inverse property. All right, we're saying that 30 plus its inverse, negative 30, is 0. Okay, and then from here to here, the difference is that I have a plus 0 here, and I don't here. So I need a reason that says that 5x plus 0 is the same thing as 5x. That's, again, the identity property. Okay, the next step, moving from here to here. There's a 1/5 that's now being multiplied on both sides. This is the multiplication property of equality. Okay, and then from here to here. On the right, I just have arithmetic again. So I've actually worked out 1/5 times negative 10 is negative 2. So ignore that, don't give a reason. Right, but notice the part on the left, we've made a small change here. 1/5 times 5x becomes, in parentheses, 1/5 times 5, with the x outside the parentheses. And we did talk about this previously as well. There's a property for this. When you see the 5 and the x smushed together, that's like an implied parentheses. So the difference here is that the parentheses has moved. In the first expression, we're grouping the 5 and the x. In the second, we're grouping the 1/5 and the 5. All right, so what property is that? That is the associative property. Okay, and then the next one. 1/5 times 5 was replaced with a 1, and there are no other changes. So this is the inverse property. Okay, 1/5 times its inverse, 5, gives you the identity 1. Alright, and then finally 1x was replaced by an x. That's the only change. That is the identity property. Alright, a couple notes about this one. Some common mistakes. Well, one common mistake is to mix up these inverse and identity properties. Alright, so a lot of people see this 0 and it's the identity, so you think, oh, that's the identity property. Alright, well, go back to what the identity property actually says, which is that something plus 0 equals itself. Alright, so in this equation, I don't have 5x plus 0 equals 5x over here, first of all. And then second of all, remember that we're justifying kind of vertically here. We're not really looking side to side. So for that step, I'm looking vertically what the change is. All right, and that vertical change has 0 as the answer. It's not like x plus 0 equals x. This one is more like x plus negative x equals 0. Okay. And then a second comment, once you get the hang of these, a lot of them follow the same sort of pattern. We may have slight variations with throwing in some properties of real numbers to sort of simplify things. All right, but for the most part, the work that you do to solve equations follows a pattern. You're either going to do an addition or subtraction property of equality, immediately followed by identity and inverse, or I'm sorry, inverse and identity. Right? Then you'll have any multiplication or division that needs to be done, and then that's going to have to be followed by inverse and identity properties. And the reason is that when we do this adding or subtracting or multiplying and dividing, we always choose the inverse because we're trying to undo things. So the only reason I multiplied on both sides was because I wanted to pick the inverse of 5 so that I could cancel it out. Right? Or up here when I subtracted 30 from both sides, I picked that specifically because I was trying to get rid of the 30 on that side of the equation. Right? So that I chose the inverse. Alright, let's try 2 more examples, and if you want to maybe just try this on your own and then check your answers, and then I'll kind of walk through an explanation, but you can skip that if you know what you're doing and you don't need the explanation. Alright, so I will assume that you've already tried this, and let me put up the answers. Now there's one step other than the first one that didn't need a justification. So occasionally that will happen. Alright, and I will walk through an explanation. If you're good to go, then just skip this and move on to the next example. Okay, the first thing that happened was that the 5y and the 2 switched places. So this is the commutative property. You're changing the order. The next change was that this y was factored out of the 5 and the 2. Alright, that's the distributive property, just in reverse. The next step, none needed. All we did is add 5 plus 2 equals 7. Then after that, there's a negative 2 that's been added to both sides. So this is, you can say either the addition or subtraction property of equality. The next step, we have arithmetic that we're ignoring. We don't need to justify a negative 2 plus 12 is 10, but we do need to justify this one. Negative 2 plus 2 is 0. That's the inverse property. Then next, 0 plus 7y is the same as 7y. That's the identity property. The next thing that happens is a 1/7 gets multiplied to both sides. That's the multiplication property of equality. You could also say division. It's like dividing by 7. And then next, 1/7 times 7 becomes 1. So that's the inverse property. And then finally, 1y becomes y. That's the identity property, that 1y equals y. All right, and then one final problem. All right, pause this and try. And I think every step does have or does need a reason. Yes. Okay, so try this, and then we will go over the answers. Okay, so the first step we have the given. The second step, now I picked this one. This is interesting because normally you might think to distribute the 5 here, but here's another option for solving equations. You can actually just move the 5 to the other side by dividing it away or by multiplying by its inverse. So you might like to do this if this number, something like the 20, is easily divisible by the number on the left. Okay, next step is the multiplication property of equality. We multiply both sides by 1/5. Then we have the inverse property. That explains why 1/5 times 5 is 1. Okay, now the next step, we had a 1 here, and now we don't. So 1 times the parentheses equals that parentheses. So that is the identity property. All right, 1 times something equals something. Next, we subtracted 6 from both sides, so that's the subtraction property of equality. You could also say addition property of equality. Then next we have 6 minus 6 is 0, that's the inverse property. And then finally, the last change is that x plus 0 is replaced with just an x, and that's the identity property. Notice that pattern again. We multiply or divide, followed by inverses and identities, then adding and subtracting, followed by inverse and identity. Okay, we will end there. So in this video we've talked about solving linear equations and then giving reasons for the steps that are used to solve.